Well, most people think that that we don't have any control over whether something's a natural disaster or not. But that's really not true. The best case I can give you is the difference between an earthquake that happens in a place like California, where maybe 100 people die, and it's a magnitude 7, and an earthquake that happens in Indonesia, or in Iran, or in Turkey, or in Utah. And in that case, the same size, same density of population, maybe even more dense in California, and thousands, sometimes in Haiti, over 200,000 people died. And it was only a magnitude, well, only, I mean, in a relative sense, it was pretty small. Magnitude 6.9 in Haiti kills over 200,000 people like that. I call that a weapon of mass destruction. Okay? And so when something like that happens, you have to ask yourself, is it possible it could happen here? And so I've tried to give you, those of you that were here before, I handed out this book right here, which was published, shows you on the back the contributors. It was published by the Division of Natural Resources of Utah, the Utah Seismic Safety Commission, and contributions from other sources. And this is a guide to help you make the decision yourself whether the earthquake's going to be a crisis, which we can't avoid that, but we can avoid it being a disaster. Because most natural disasters are really human disasters, meaning that the people are living in a situation where there's very low resiliency. They're vulnerable because they live in homes that aren't built to seismic code, or they're living next to a hillside which has unstable rocks or unstable soil, or they're living right beneath a dam that isn't built to seismic code, or a lot of other things, or they haven't secured things in their home, like they have lots of things that are up high that are going to fall, or big bookshelves, or water heaters that aren't secured that are going to rip off and cause a fire in their home. So those are things that we can control. And most people have no idea what those things are. Okay. All right. And so that's what I wanted to just briefly talk about today, is what some of those hazards are. First of all, if you look at the first few pages of the book, from page 6, it starts talking about what the Wasatch Fault is and why we should be concerned. For example, actually, if you go to page 4, you can see right here a table of historical earthquakes in Utah since 1884. There's 15 of them there, right? And the last one was in 1992. That's been over 20 years ago. Now, if you count those 15 earthquakes and divide by the amount of time, that's an earthquake every about, sorry about that, that was an earthquake right there for my ear. That's an earthquake, one, and let's see, it's 112 years, 15 earthquakes, you know. So we're, according to this, we're overdue for a small one somewhere in Utah. Very few times, if you look at that list, did it ever go more than 20 years without an earthquake. We're already 22 past the last one. Okay? So those are the small ones. Another one that's not on this list was an earthquake in Provo in 1915. The earthquake in Provo was probably about a magnitude 5.3, which is why it's not on the list. But it cracked the courthouse. It damaged the original tabernacle, which is why they tore down the big spire and had to rebuild a new one. And it also caused a wave on Utah Lake that flooded the eastern shore. It also caused lots of rock falls and landslides. Most anybody who had a chimney, the chimney fell. And it was only a magnitude 5.3. And the way the earthquake scale goes is that each whole number is an order of magnitude or 10 times greater than the previous one. So a magnitude 5.3 is 10 times smaller than a magnitude 6.3. What we're expecting to have on the Wasatch Front is a 7.3, which means that 5.3 we had in 1915 was 100th of the size of the one we're expecting, and 300th of the amount of energy that the one we're expecting. Okay?
So what about the dam up the Provo Canyon?
So Deer Creek Dam. Yeah, there's actually two dams up Provo Canyon. There's Deer Creek and there's Jordanelle.
Oh, yeah.
Right? And Deer Creek, actually about 5 years ago, had some construction done on it to try to make it more earthquake safe, because it was sitting on liquefiable sand. So they tried to dig as much of that liquefiable sand out from underneath the dam as possible, and then prevented cars from going over it. That Deer Creek Dam was constructed the same way as the Teton Dam in Idaho, which collapsed just because it was poorly constructed. No earthquake. So that's a real problem. Deer Creek was leaking, yeah. Yeah. And so they've tried to retrofit it, but it's still a real problem. And those kind of things, like a dam, are what we call secondary hazards, things that the earthquake caused, which causes another hazard, like a landslide, or like a dam breaking, or like something in your house falling on you, or a collapsed building, right? So, why is this not advancing? Oh, there we go. Okay, so why should you care? Well, like I said, we have this weapon of mass destruction that we're living on, and earthquakes are preventable. Earthquake disasters are preventable if you are prepared. And so this is the problem. Okay? I don't like to read off these slides, but it's important to read this one. The earthquake threat to many populated regions, including Utah, is well known. And that's what this book is about, is what we know about the earthquake threat. Okay? We know where it's going to happen. If you go to page 7, you can look at this graph here. It shows a map of the Wasatch Fault. The Wasatch Fault is made up of several different sections. And each section kind of has its own little history, right? And there have been trenches like the one in the picture here that have been excavated along those fault zones to get an understanding of the history of earthquakes along each one of these segments. You can see it goes back 10,000 years. And the reason it only goes back 10,000 years is because we can't dig the trenches very deep. But the Wasatch Fault is actually much, much older than that. In fact, the whole valley here, we call Utah Valley or Salt Lake Valley, it's a rift valley. It's an earthquake valley. There's no river that made this valley. Okay? What's happening is that one earthquake at a time, the valley's dropping. I'll show you what I mean. So here's an animation which I made to kind of show you how the Wasatch Range formed. So these are the layers of rock we call sedimentary rocks. Oh, it's too bad. These tents are in the way. Oh, you can see Timp right over there. You can see those layered rocks on Timp, right? All of those layered rocks on Timp have marine fossils in them. Those are seabeds, right? So how did those seabeds get up at that elevation? Well, this is the seabeds being deposited, and then this is the big thick limestone which makes up Timpanogos right there. It's kind of nice to have Timpanogos for a little visual aid. Yeah, that's what I was trying to find. And then what happened is those seabeds were scrunched. If you go up Rock Canyon, you can see beautiful folds in the rock, and in Provo Canyon and so on. And so those seabeds were lifted up to the elevation that they are now by two plates colliding. But then what happened is that collision stopped, and that big bulldozed mound we call the Rocky Mountains started to collapse back towards the west. which is what it's doing now. So this is the birth of the Wasatch Fault right here. You can see that it's making this big edge in the topography, right? And when that erodes, it fills the valley here with sand and mud. Okay? And that's the birth of Utah Valley. It's not by a river, it's by one earthquake at a time. This is showing you thousands of earthquakes, because when that thing moves down, it doesn't do it slowly. It sticks and then slips. It sticks and then slips, and each time it slips, there's an earthquake, right? So I think there's a scripture somewhere about foolish people building houses on sand. Yeah, sorry about that, but you guys didn't know, right? And neither did the pioneers when they came here. In fact, they misinterpreted what Brigham Young said. When he said this is the place, he was really meaning this is the place where there's going to be a whopper of an earthquake. But, he was delirious, and so, they didn't... Anyway, so here we are. Here's Y Mountain right here. Here's the Wasatch Fault going right underneath Utah Valley at an angle of 40 degrees. And here's where all the people in Utah Valley live, is right on top of the fault zone. And these little things right here are called lake terraces when Lake Bonneville was here. And those lake terraces have been offset by the Wasatch Fault 30 meters, so that's over 100 feet, since they formed. And they only formed 15,000 years ago, which in geologic time is very, very recently. So the fault is still alive and well. When I first moved here in 1998, the attitude that I heard was, well, it's got temples all along it. So how can it be active? The temples are like nails that are kind of making sure the fault won't move, right? No, the temples are there to educate us, right? So that we can be listening to the Spirit, and the Spirit right now is telling you that this fault is active. There, as it says here, if you go to page 4, it shows all the earthquakes plotted in Utah over the last, since 1964. There have been, I think it says, 36,000 earthquakes since 1962. So it's stuck, and it's sitting there, and it's very, very weak. It could go at any time. People are always like, well, when's it going to happen? Right? My answer, wrong question. Well, why is that the wrong question? Because you cannot know when it's going to happen. The right question is, I'm convinced it's going to happen, so what do I need to do to get ready? Right? There's also a scripture about some wise and foolish virgins. 5 were wise, and they said, when I gave a talk, oh, there's going to be an earthquake, so I need to go get ready. Right? And so they went and they took care of everything. They took care of their home. They made sure the school their kids went to was retrofitted. They made sure that their neighbor's home was also, because if their neighbor's home burns, then their home's going to burn too. And they did something about it. And when the earthquake happened, the 5 neighbors that weren't ready came to the ones who were when the ground was shaking and said, help me, help me, help me. And the 5 that were ready were like, the ground's shaking. I can't help you. It's too late. Right? So there's a disaster on one side of the street, and there's a crisis on the other side of the street. And it was the decision of the people. One got ready, and the other thought, like the 5 unwise virgins, well, we'll just procrastinate. Right? It won't happen to me. It won't happen here. Earthquakes only happen in California or some other part of the world. Right? Okay. So this is essentially another drawing of the Wasatch Fault. So here I am flying in, and the Wasatch Front, we call it, really is misnamed. Whenever you hear the word Wasatch Front from now on, you just need to substitute fault for it, right? Oh, we live on the Wasatch Fault, right? There's 2 million people that live along the Wasatch Fault, and most of their buildings are not built to seismic code, right? So in a very simplistic way, we built the Rocky Mountains like this, like building an arch, and now what's happening is one of those people that push the arch up is pushing this part of the arch to the west, and here's the keystone right here. And that yellow stuff right there is what we're sitting on right now. And that thing is dropping one earthquake at a time, and each time it drops, there's a magnitude 7 event. Okay? So this is a rift valley right here. Not made by a stream, It's made by pulling 2 blocks apart. And that's what we live in. So here's our Rift Valley right here. And here's the Wasatch Fault. This is where we're sitting right now. You can see it snakes right along the break and slope between the valley and the mountains. And it's a whole zone of fractures. The current code in Utah is that you have to build 40 feet from a little pencil line on a map. But there are schools and other public buildings and lots of homes that are built within this anastomosing set of fractures here, which is actually in the Wasatch Fault itself. Okay? So now I want you to do a little exercise and see how good of a predictor you are. Here's a brick, and it's attached to a spring. The spring is representing tectonic motion, this stretching apart of the crust, right? And the brick is the fault sitting on itself, on the side of the mountains, the valley sitting on the mountains, and it's stuck there, okay? So I want you to raise your hand at the exact moment that that brick's going to slide, all right? And then you'll know why when people call me and ask me why I can't tell them when it's going to happen. I don't know if you can see the spring, but it's stretching. Oh, there it goes. You guys all missed it. Here's another one. Oh, there it goes. Shall we watch it again? Okay, let's watch it again. Now this time you've had a little bit of experience. Okay, you're crying wolf. Nobody's going to believe us now. There, okay, a little bit better. If anybody tells you that they know when there's going to be an earthquake that's going to happen, they give you a date or a year or a month, you can immediately discredit them. Because it's impossible with the science that we have now to know exactly when that thing's going to move. Especially when the interval between movements is thousands of years or hundreds of years, right? Okay, here's another experiment that we did. This is on a piano top, okay? And every time my wife sees this, she's like, you used a piano top. So look, we're rolling this spring in, and there's an earthquake there, and then it sits for 100 years, and then another earthquake. And you can see that sometimes it slides a lot, sometimes it slides a little, right? No earthquake, nothing's going to happen. What do you mean there's an earthquake? You know, and then all of a sudden it goes, right? So even when we have a predictable surface and this constant rate of reeling this thing in, it goes at different times and in different ways, okay? So you can't predict it. So the best question to ask is what you need to do. That's what the rest of this is about. If you go to page 10, it says what kind of damage the earthquake does. All these different ways. And then it talks about building codes. Now the only thing I don't like about this book right here is page 15. And this is what I do to page 15. Okay? Because page 15 is wrong. And page 15 is inaccurate. And let me tell you why. Page 15 is driven by people who want to have certainty. And they want us to predict a probability of earthquake happening in a certain place. And when you have a system like this going on, there's no way that you can come up with probabilities. But they do this for builders. They do this for insurance companies and stuff like that. So it tells you here that there's a 1 in 450 chance of an earthquake along the Salt Lake City segment. Now that's just wrong. Okay? And I'll show you why. Okay? I'll come back to these animations in just a second. Here's why that's wrong. Okay? We haven't had an earthquake in Salt Lake City since 1,350 years ago. And the average recurrence interval of an earthquake in Salt Lake City is about 1,300 years. So 1,350 years ago, there was an earthquake that released all of the strain in that spring. So essentially the brick moved, right? And on average, it takes 1,300 years for that spring to go and for the brick to move. Well, the spring has already been being pulled for 1,350 years. It's like we have a weapon of mass destruction underneath Salt Lake City, and when it goes off, it's going to be like 100 Hiroshima bombs buried 10 miles down, right? And it's got a fuse that's 1,300 years long, and it's already been burning for 1,350 years. So the probability is actually higher the closer you get to the recurrence interval time, which this page right here doesn't take into account. And so that's why you can rip that one up. And there's nothing really good on the other side either. Something about how to save a dog or something. I don't know. Okay. So this is the record from Salt Lake City here. This is time present to 6,000 years ago. And this is what we find. We find the whole Salt Lake Valley dropped 2.2 meters. So that's like 7 feet at the speed of sound. 5,400 years ago. And then nothing happened. And then it dropped here at least a meter. And then it dropped here 2.6. So we're getting close to like 8 feet. And then it went for another long time. This is the last one, 1,350 years ago. The earthquake dropped the valley, the whole valley, at the speed of sound, 2.3 meters. And then it's been 1,350 years. If you look at this pattern, we're overdue, no matter how you look at it. The problem is that in Salt Lake City, nobody really understood this until the last couple decades. So we have over 200,000 buildings in Salt Lake City that are built by unreinforced masonry construction. And that means there's no reinforcement in these buildings at all. That includes the Salt Lake Temple. Okay? And yes, I have talked to President Hinckley about it personally, right? And something's supposed to be being done about it, but it hasn't been done yet. So the church office building, built in the 70s to withstand a magnitude 5 earthquake. I have friends who work in that building. I go, you got to do something about it. You can't just go back to work in that building, Look at the data here. This could happen today and it would not be a surprise, right? Okay, so now let's go back and see what's going to happen during an earthquake. This is a model, okay? So here's the Wasatch Front right here, right there. This is Cascade Mountain. We're sitting right here, okay? Here's the fault coming down underneath us. It breaks, and look at the sound waves that it creates. Those shock waves are really just really low frequency sound waves, and they reverberate through the entire valley. And I want you to notice which way things move. I'm going to show you again. This is a seismometer, which is what we use to record these things. But which way do things move, okay? Do they move up and down, or do they move side to side? Watch. Boom, they move side to side, and that's why they're so dangerous. This building right here, I am so glad we're not meeting in this building right here. I don't know if it's been retrofitted, but it looks like a death trap, right? Those bricks are probably over 100 years old, or close to it, and the mortar between them is even weaker than the bricks. The mortar is horizontal, and that's the way things move, and that's why those things just collapse. I've been in earthquakes, and I've seen that, and I've experienced it, and I am so scared. There's no way I would even walk into that building, knowing what I do about when the earthquake is due to happen and that thing is not going to perform well. Okay? Some of you might live in homes that were built before 1980, right? You need to check that home. You need to have a structural engineer come and check it, right? Some of you live in wood-framed homes, and that's great. That's the best type of building to have. If you go to the back part of this one-page missing pamphlet, it talks about step 1, identify potential hazards in your home and begin to fix them. Has a checklist, a great thing for a family home evening. Number 2, create a disaster preparedness plan, right? Notice that number 1 is not go get a 72-hour kit. What good is a 72-hour kit going to do you if you're buried under bricks? So people think that getting ready for an earthquake is to go get a 72-hour kit. It's the kind of stuff that the 5 wise virgins would do, right? You don't try to get ready for being comfortable after the earthquake. You try to get ready to survive. Okay, this is what we're going to experience when we have our earthquake. This is from Kobe, Japan. Actually, that's a picture of Seattle. But this is some footage from Kobe, Japan here. Why are there fires? Because gas lines are rupturing, right? Look at the sidewards motion here. Okay? Notice that there's lots of people that are homeless because their homes are destroyed. Look at this. Okay, I need to stop there. Oh, whoops. Go back. Okay, let's start this again. You need to watch this, the different way these two people react. Okay, one of them ducks and covers, and the other one ducks and comes back up, right? Here it comes, here it comes. They're right here. Watch this guy in the striped shirt. The other guy ducks and covers and holds on. Oh my goodness, this thing stops right before that thing's ready to fall on the guy. Okay? So what do? No, you don't try to run to a door jamb. Right? You can't run anyway when there's a magnitude 7.0 event. You're on the ground. And no, you don't try to find a triangle of life somewhere. And you definitely don't tell your kid that. Right? What you do is wherever you are, you duck and cover your head and hold on. And as soon as the shaking stops, you get out of the building if you're in a building. If you're near a building and the shaking's going, then you don't have to worry as much. You just need to get away from the building, especially if you're on Temple Square. Okay? Because those big blocks of granite are going to be flying down, and there's going to be glass in the church office building that's going to blow out and be coming down like a guillotine. Right? And so, notice that what happens to the railway system here. There's a house right there, a house right here that wasn't attached to its foundation. If you have an unfinished basement and your house was built in the 80s, even the 90s, you need to go and check to make sure that the wood frame is actually attached to the basement. There's a lot of them that aren't. Okay, most of the ones in my neighborhood are not. We've been systematically going through them and trying to repair that. Here's the railway system. This is a foreshadowing of what's Salt Lake City's going to look like. Okay, so again, okay, I'll just conclude then. All right. Here's the problem. We have all these earthquakes on other segments, but the Salt Lake City segment has not had one for a long time. It's not because the fault's dead. It's because the longer it waits, the larger the earthquake's going to be. Okay? And President Benson said this about earthquakes and other things. Too often we bask in our comfortable complacency and rationalize that the ravages of war, economic disaster, famine, and earthquake cannot happen here. Those who smugly think that these calamities will not happen, that they somehow will be set aside because of the righteousness of the saints, are deceived and will rue the day that they harbored such delusions. No. We're not going to just be protected because of our righteousness. We're accountable to make sure that the earthquake is not a disaster. Thank you.